Imagine a world where cities grow sustainably and inclusively, where every resident has access to vital services like healthcare, education, and transportation, regardless of where they live. Today, over 1 billion people live in informal settlements. These areas are disconnected from essential facilities and infrastructure, leaving millions vulnerable to inequities and environmental risks. But what if we could reimagine these settlements, not as challenges, but as opportunities to build inclusive, thriving communities with improved connectivity and access to critical services? Urban populations are growing rapidly. By 2050, nearly all urban expansion will take place in the less developed regions, with 3 countries, India, China, and Nigeria, accounting for 35% of this growth. These settlements face critical challenges. Poorly serviced areas remain disconnected from the healthcare, schools, and transport networks, making essential services inaccessible for millions. Without planned road networks or proximity to vital infrastructure, residents are more vulnerable to emergencies and disasters, while women and children suffer the most from unsafe conditions and lack of opportunities.
Our solution begins with importing Kibera's digital elevated model from Copernicus, which is an open source data platform. We then, from OpenStreetMap, we can get the residential areas or areas where we have lots of settlements. We then import the existing road networks in the constituency. We also import all the healthcare and social facilities. This basic idea is to figure out which areas are underserved in terms of the facilities and similarly the transport networks. So we do this by first creating buffer zones around the healthcare and social facilities. We then calculate the difference between the settlement areas and the social facilities and the hospitals. So this will create a polygon which can be seen here. We now from the polygons find centroids and figure out potential places where we can put the facilities which can be seen in the map. And then finally, from using Python's API, we wrote very elementary code here to figure out the minimum spanning tree across the key areas of the nodes, which results into the proposed road network as seen. There it is. Now we had to adjust it to follow the contours so that we don't have cases of flooding, and that's why it's not particularly a tree, because sometimes it crosses roads and other facilities, so we had to adjust that. That is simply the solution.
Our project directly contributes to achieving multiple sustainable development goals. SDG 1, no poverty. Improved access to schools and healthcare empowers communities to break the cycle of poverty. SDG 3, that's good health and well-being. Shorten distances and better access to healthcare and sanitation ensure faster response times and better health outcomes for the community. SDG 9, that's industry, innovation, and infrastructure. The optimized transport networks enable better connectivity and economic opportunities. SDG 11, sustainable cities. Building inclusive, accessible neighborhoods integrates informal settlements into the urban fabric. SDG 13, climate action. Infrastructure planning reduces disaster risks, strengthens resilience, promotes sustainability, and these improvements lay the groundwork for a fairer, more connected world where the underserved areas become centers of opportunity. This is more than infrastructure. It's about building communities that thrive on inclusion, opportunity, and resilience. With innovative tools and strong partnerships, we can close the gaps in underserved areas and create cities for everyone. Let's build a future where no one is left behind. A future in informal settlements, transformed into thriving, sustainable neighborhoods.